Azure Synapse Analytics is a limitless analytics service that brings together data integration, enterprise data warehousing, and big data analytics in a single unified and integrated service. It gives us the freedom to query the data on our own terms using either serverless or dedicated resources at scale. I'm Arshad Ali, and in this first series, I'm going to walk you through Azure Synapse Analytics from end-to-end perspective. In this first video, I'm going to get you introduced to Azure Synapse Analytics and get you started with your first Azure Synapse Analytics workspace. As per a study done by Harvard Business Review, analytics and AI is the #1 investment for business leaders. However, they struggle to maximize their return of investment. 80% of these business leaders reported that they struggle to become mature users of the data. 55% of these business leaders reported that data silos and data management are the roadblock to maximize the return of investment. With this, businesses are forced to maintain two critical yet independent analytics systems. What we see on the right side is business analytics system, which is built on enterprise data warehouse. This type of system has matured over a period of time. This is mostly based on relational database engine and processes structural data. This has dependable performance because as it has matured over a period of time, this also has proven security and privacy capabilities. On the left side, we have newer data lake architecture or workload to enlighten data science and machine learning development. This kind of system is based on big data. It allows you to store semi-structured, unstructured data into it and allows fast exploration of data. With Azure Synapse Analytics, Azure meets these challenges with a single service to provide limitless analytics. Welcome to Limitless Analytics with Azure Synapse Analytics that includes data warehousing and big data analytics all in one single service. So what is Azure Synapse Analytics? It's a limitless analytics service with unmatched time to insight that delivers insight from all your data across data warehouses and big data analytics system with blazing speed. Azure Synapse Analytics provides an integrated and unified platform to integrate data from Azure Data Lake Store, and that integration is already built in. It also provides or has integrated foundational capabilities for management, security, monitoring, and metadata store. The data integration layer of Azure Synapse Analytics allows us to connect to a data lake store and query the data and bring the data into Synapse Analytics for further processing. There are two types of analytics runtime that empowers Azure Synapse Analytics. On the right side, we see Apache Spark-based compute, which allows us to do big data processing with Python, Scala, or .NET programming language. On the left side, we see T-SQL-based SQL engine, which allows us to process the data in a interactive batch streaming mode. In the context of Azure Synapse Analytics, Apache Spark Pool Compute Engine or analytic runtime is called as a Spark Pool, and SQL runtime is called as SQL Pool. SQL Pool has two form factors: dedicated, which is ideal for data warehousing kind of scenario where you want to have dedicated resources to respond to your interactive queries. Serverless form factor is applicable in the scenario where you want to do data exploration or data processing of data sitting into data lake store in on-demand fashion. From the consumption and costing perspective, for dedicated pool, you pay for the resources as long as you are using it. With serverless, you pay for the amount of data that you are processing, or basically you pay for per query processing. Synapse supports multiple programming languages to write your data transformation on machine learning model in it, and based on your preference you can choose either of these. All of these capabilities are enlightened with Synapse Analytics Studio. Having said that, Azure Synapse Analytics is a unified and integrated service for a variety of different types of workload, whether it's interactive querying, batch processing, real-time stream processing, and machine learning. In the next couple of videos, we will get into deeper level in SQL Pool engine, and subsequently we'll get into Spark Pool. But before that, let's take a step back and understand the difference between SMP versus MPP and SQL Pool architecture. SMP is short for Symmetric Multiprocessing. It's a computing architecture based on a scale-of pattern. In this architecture, you have a single machine, and when you need more resources, you keep on adding more resources to that single machine. As you can imagine, there is a limit in terms of how much resources you can put to that single machine. So your computing architecture or computing infrastructure is limited by that constraint. In this computing architecture, there is only one server, and each CPU in the server shares the same memory, disk, and network controllers. And as I said earlier, this architecture is called as scale-up architecture. The next one is MPP, massively parallel processing. This architecture is based on a scale-out pattern, where you have multiple nodes working together to do the processing. As you need more nodes, you keep adding more nodes to this infrastructure to get higher computing power. MPP means data is distributed among many independent servers running in parallel, and it is based on shared nothing architecture, which means each server operates self-sufficiently and controls its own memory and disk. So with this architecture, as you can imagine, there is no limit in terms of the amount of computing resources that you can bring into this infrastructure. If you need more resources, you can bring more hardware to it, or more servers to this computing infrastructure, and you can get higher computing power. SQL Pool is based on MPP architecture. As you can see in this diagram, all the application and user connects to the master node called as control node, and that control node connects to multiple compute node. The number of compute node can vary based on your requirement. It can be from 1 node to 60 nodes based on your requirement. You can all the way scale from 1 node to 60 nodes in SQL Pool based on your requirement. What is also important to note here is that Azure storage, right? So in this architecture, in this MPP architecture for SQL Pool, compute infrastructure is separated from storage infrastructure. That gives us a couple of benefits. The very first one is both of these resources can scale independently from each other. The second thing is, when you don't need compute infrastructure, say for example off-peak hour or during night time, you can pause the compute resources, or you can scale down the compute resources to save on cost. And as we know, in this whole architecture, the most expensive part is the compute resources. If we optimize the utilization of compute resources, we can save a great deal on this whole infrastructure. Now is the time to roll up our sleeves and get started with Azure Synapse Analytics. To get started, let's go to Microsoft Azure portal. To go to Microsoft Azure portal, go to a browser and type portal.azure.com. If you are new to Azure, you'll have to first create Azure account, and I'll include link in the description on how to create that account. Once you are on Azure portal, you'll see this search box on the top of this screen. This is where you can type Azure Synapse, and we'll see Azure Synapse Analytics as one of the service on Azure. Click on this. This will take us to a screen where we can see all the Azure Synapse Analytics workspaces created so far in the selected subscription. We want to create another one. Click on this create button. Then the very first one selection here is the subscription under which we are trying to create this Azure Synapse Analytics workspace. Then we have to specify the name of the resource group. Think of a resource group as a logical container where all the resources will reside. So we can select from a list of all the resource groups that we have created so far, or we can create another one, right? So for example, in this case, let's say we are creating another one. So I'll give a name here and click OK, and let's go to the next one. For the workspace name, so what we have specified so far is the resource group name where this resource will exist. Now we have to specify the name of the workspace. This has to be unique, so I'll give a name which is unique. And then finally I have to select the data center or the region where this service will be hosted, right? So I'm in US West or US Pacific West, so I'll say select West. You can select region based on your location or based on your preference. Then we need to specify a name for Azure Data Lake storage account. So that's going to be a default storage account for your workspace. I can give the same name here, what I have given it for my workspace. By default, it's going to include my user credential as part of Azure storage blob data contributor role, right? So in order to access storage account from Azure Synapse Workspace, I need to be part of that group, and it's including me in that group. If you want to add another user to your workspace, you have to make sure you are adding that user to a storage blob data contributor role so that the user can access file sitting on this data lake store. Click on next. This will take us to another screen where we need to specify the SQL admin user ID and password, right? So let me give a name here. Then password, something that is strong enough. There are a couple of other settings on the bottom of this screen. Let's go with the default one. I'll have another video where I'll talk in detail about security, encryption and all those things, but for now let's keep it default and let's go to the next one. On the next screen also, let's keep everything as default. It's about how you can secure a network, but we'll keep it default for now for simplicity's sake. And finally, on the tags screen, you can put a tag for these resources that enables you to categorize your resources and view consolidated billing by applying same tag to multiple resources in a resource group. I'll go ahead and click on next, right? So this is where it validates all the information that we have provided. We have missed some information here, so it's saying validation failed. So I'll have to go to the basic tab where I need to provide some more information. So I can come here and I can give the name that I have given earlier for storage account. This is going to be the name for the file system account, right? Then I can go ahead and say review and create. At this point I see the validation passed, and I can click on create, and it will take a couple of minutes to create my first Synapse workspace. I have already created a workspace, so I'll not create it again, but this is a place where you'll get started with the workspace. To go back to my existing workspace, I can come back on Azure portal and I can type Azure Synapse Analytics again, and this is what I'm going to select. This is listing all the Azure Synapse Analytics workspace created so far. I'm going to work on this one. Let me click on this. This is where you'll see all the details related to my workspace. There are certain things that we have to note from here. The very first one is, if we go down on this overview page, you'll see that there is one built-in SQL pool created, which is of type serverless, and size is set to auto. It means there is a serverless SQL pool already created for us to simply go ahead and start executing the query. So if we have a need of running on demand ad hoc data exploration and data transformation need, you can simply go ahead and use this SQL pool and pay for the amount of data that you are processing. What we are going to do now from here is we are going to create a dedicated pool, and to do that, you see that there are multiple options on top of this overview page. Let me click on new dedicated SQL pool. This is where I need to specify the name for the pool. I'm going to give a name. This pool is going to be also the name for the database, and then I can select the database size. Right, so if you remember from our earlier discussion, dedicated pool is based on MPP architecture, where we have control node and multiple compute node. So in this case, based on the service tier or performance level that we are choosing, the number of compute nodes will be determined. I'm going to include this into description, but here is the details, right? So the level can be from all the way from DW 100C to DW 30,000C, and for every increase in 500 in DWC, you'll see a new compute node getting added. For example, for DW 500C, there is only one compute node. For DW 2000C, there are 4 compute nodes. Likewise, for DW 5000C, there are 10 compute nodes. So based on your need, you can have bigger database if you want to process large amount of data. I'll go back here and I'll select DW 1000C for now, and you can change it by dragging this slider based on your need. I'm going to keep it at 1000. Let me go here and say 1000, right? And this gives us the estimated cost per hour for the performance level that we have selected. On the next screen, we can create this database as an empty database, or we can create this database by restoring the backup that we have, or by taking the restore point from the existing workspace. For now, let's go ahead and say create blank database. Again, we can specify tag to categorize and view consolidated billing based on tag. For now, I'll keep it empty. Let's go to the next screen. And at this point of time, the validation has passed. I can go ahead and click on create. This will take a couple of minutes to create the database for me. Okay, so our database is created now. Let's go back to our workspace one more time. We'll come here on the home page of Azure portal, click on the Synapse workspace link here. This will take us to the overview page of the Synapse workspace, and at this point of time you'll see the database is created. We named it as Learn Synapse TV, and it is of type dedicated, and this is the size that we specified for the database. So this is how we can create multiple database or dedicated SQL pool by going to new dedicated SQL pool link here. You will also see a link to create a new Apache Spark pool. I'll talk about this in future video. At this point, now we are all set, and we can open Synapse Studio to do the development, management, and monitoring of our workspace and the work that we are doing. However, if you prefer using desktop tool to work with the database, you can do this with SQL Server Management Studio or Azure Data Studio. To do that, you need to pick up the dedicated SQL endpoint. This is going to be the name of the server to which you will be connecting to. Let's go to Management Studio. Let's click on database engine to which we want to connect to. Let's specify the name of the endpoint that we have, right? So this is the endpoint that we have, and then specify the login ID and the password, and click on connect. While this connecting, SQL Server Management Studio is a free tool which you can download and install it on your local machine. Once we are connected here, you will see your database that we created earlier, right? So Learn Synapse TV is the database that we created here. At this point of time, we do not have any objects because we created an empty database. Let's go ahead and create some sample database. To install or kind of set up this sample database worldwide importers, let's go to Management Studio, and I have copied the code from official documentation here. So let me open this code here. This code uses Polybase to kind of ingest data from storage account. We will go into details about Polybase and how it works, but for now let's run the code as is to create the external table. I've already copied the code from official documentation to create this Polybase external table. Let's go ahead and run it. This creates external data source and external file format. Next, we are going to create the schema, a schema to kind of store all the external table, and then one schema to store all the internal tables. Let's go ahead and run this, and let's create the tables. So once we execute this command, this is going to be creating the all these external tables, in which case the metadata for these tables are going to be stored as part of the database, but the data will reside on the data lake store to which it's pointing to. If you're coming from big data background, you will know that there are two types of table, managed table and unmanaged table. So unmanaged tables are the tables which has metadata stored in the engine itself and the data resides outside. This, you can think of this as an unmanaged table. We can come back here and we can refresh to see all those tables created. So these are all external table. Now what we can do is we can go ahead and we can create internal tables and populate the data from this external table so that we can work in the database. Once we have all our external table created, we can go ahead and create internal tables and load data into those internal tables via external tables. To do that, let me kind of open the code which does that, and again I have copied this code from the official documentation, and I'll include the link of this code in the description. What we see here in this code is it's creating a table, create table, and specifying the name, and this table is going to be in WWI schema, and there are certain parameters that we are specifying as part of this table definition, right? So distribution is equal to replicate and cluster column is to index, right? And then we are selecting the data from that external table to create this table, right? So this is one definition to create one table. Likewise, if we go here, we'll see another definition where we have a different types of distribution. If we come here, we see we are saying create table and name of the table, and the distribution here is has based on the movement key column, and in this case the data is coming from fact movement external table. In my next video, I'm going to talk about distribution strategy, and what are the best practices. That's a core concept of MPP engine, and I'm going to go into more details about how this distribution works and what are the best practices that we have to be aware of. For now, let's execute this code and create all those internal tables. This is going to take a couple of minutes based on your database size. So we can see that the code has executed, and if we come here and refresh, we can see all the tables here created, right? So if we can expand this, we'll see all the external tables listed here under external tables, and these are all internal tables created. This internal tables contains the data. When we executed this code, it pulled all the data from external table and ingested into internal table. Once we have this table here, we can go ahead and write our code to do all sorts of transformation or whatever we have to do as per our business need. This as SQL Server Management Studio is a management tool mainly meant for managing the database, and people also use it for development, but this tool is only available on Windows platform. If you want to use it on a different platform, Microsoft also provides a free tool called Azure Data Studio, which you can download on, say, MacBook, to kind of connect to Azure SQL dedicated pool. To do that, once you have installed here, you can come here and you can click on new connection. This will take you to this page where you can again specify the name of the server, the endpoint that we copied from Synapse workspace overview page, and then you can specify the user ID and password and click on connect. This will connect us to the same server, and if we expand this, we'll be able to see the database that we have on that server. Let's expand this, and this is where you'll see all the tables that we have created. Or it also provides notebook experience. So let me show you first query, and then I'll show you the notebook experience. By clicking on new query, we have this query window where we can write our query. So let me start with selecting some data from one of the table that we have here, right? If we run this, you'll see we'll see the data coming up over here, right? So this is query window experience. For notebook experience, we can come to the database, click on this database, say create new notebook. We can come here and we can add a cell, code cell, where we can have this code, and we can execute this. You'll see the data coming in from this table. We can add more cell here, code cell, and we can add another command here. Say for example, we want to select from customer, right? And we can execute. So this is how you can keep on creating multiple cells with different commands in a notebook experience. So these are two desktop tools to connect to dedicated SQL pool as well as on-demand SQL pool. To connect to on-demand SQL pool, we have to use a different endpoint, and this is how it looks like. If we go back to our overview page of the Synapse workspace, you'll see there is another endpoint for serverless SQL endpoint. So if we want to connect to on-demand or serverless pool, we have to use this endpoint or this as a server name when we are connecting through those tools. With that, let's get started and go to the Synapse Studio. And this is how Synapse Studio looks like, right? So on the home page, you'll see there are multiple options here on the left side. Let's go to data, and on the data page we'll see the databases that we have created so far. In our case, we have created one database. If we expand it here, we can see the tables that we have created, those external tables as well as the internal tables. So these are all internal tables. To see external tables, we can click on external tables and we can see all the tables that we have created. We can go ahead and we can start writing our query here. We can create a new SQL query window and go ahead here and specify the command that we want to execute to. No, this is not the one. Say we want to execute select star from wwi dot dimension city, and we want to select only few records. Run this and we can see the data here. So this way you can keep on adding SQL script in browser experience in Synapse Studio. Once you have kind of made the changes, you can save these changes by clicking on publish. So this is about databases on the data page. You can click on link here, and this is where you'll see the link for all the storage account that you have in this workspace connected to, right? So we have one default primary storage account that we are connected to, and this is what we are seeing right now. But we can add more and more storage account if we have to connect to it, right? So if we can click on this will take you to a page where it will give you a file explorer like experience. I have this folder in this data lake storage account. If I go here, click on this folder, this will give me a list of all the files in that folder. This is another folder inside that. And what is the good part here is, like on any of this file, if I want to see the data inside it, I can simply go ahead, right click on this, and then I have an option to either query the data sitting on that file using T-SQL or create a notebook in to query the data in a Spark as a data frame, right? So let me show you T-SQL based method here. So this is the command that it uses to query the data sitting in the data lake store, open row set method, right? If we can go ahead and execute this, we'll be able to see all the data coming in from the file sitting on the data lake store in our engine here. Sorry, I have to select the whole command and run it, and this is where you'll see the data coming from the files from the data lake store. On the develop screen, we'll see all the development work that we are doing, right? So far we created multiple SQL script file, and this is what we see over here. We can switch back and forth between these files. You can also create notebook to work with Spark in Synapse Studio. We do not have a notebook so far, so we are not seeing it here, but we can click on this and it will allow us to create a SQL script or notebook or data flow, or even the job Apache Spark job definition. Next, we can click on integrate to create data processing pipeline. So you can create a pipeline all the way from ingesting data from your source system to the SQL pool and doing all sorts of processing. So all the scheduling, orchestration, data flow to kind of process the data while it's getting loaded. This all can be done with integrate pane that we see here on the Synapse Studio. On the monitor tab or in the pane that we have here, we can go and monitor all the queries that is running right now, right? So for now we have SQL request only, and if we can click on this, it will show us all the SQL requests that we have run or running at this point of time. So these are the two commands that has completed. This is what we see here. On the next, we can go to manage tab to manage the different engines that we have, right? So for example, if we want to create a new pool, right? So if you remember, we created this dedicated SQL pool in Azure portal, but that's not the only option. If you are in Azure Synapse Studio and if you have sufficient privilege, you can create new SQL pool from here as well. Likewise, you can also create Apache Spark pool from Synapse Studio if you have the sufficient privilege. Then you can link this workspace with Git so that your code that you are making changes to are getting committed into a Git repository. And then you can manage all sorts of resources from here. Then you can go to access control to manage permission and access to this workspace. So with that, let me go back again on the home page, and this is what we see, right? So this is Synapse Studio, which provides a comprehensive, integrated, unified platform for your end-to-end analytical need. This provides functionality and feature for all types of workload, whether it's interactive querying, batch processing, stream processing, or machine learning. With that, let me close this video, and we'll come back again in the next video where we'll talk about how data gets distributed. What are the different ways we can control to make sure the data is evenly distributed across all your nodes so that all your nodes are working efficiently. What are the best practices around that? We'll go into that detail. Till then, thank you for watching. See you then.